Hey everyone, and welcome back. Before we begin here today, please make sure that you like and subscribe because it really does help out our channel. And it also helps us reach others who want to test their math skills with these types of test questions. So this will be our 20th part in this math skills test series. So we have this picture on the left and a long description here on the right. So it says, determine the area of green for this eye-shaped member. The bottom of the top flange, which is right here. So this is your top flange, and this is the bottom of the top flange. And the top of the bottom flange, so this would be your bottom flange, and here's the top. So we're talking about this line right here and this line right here, are both tangent to the circle, which has a center at point F right here. Points A and F align vertically. So here's A right here. Points D, C, and E also align vertically. So D is the corner of our flange, C is right here, and E is the corner of this flange. The distance from A to B is 42 inches. The distance from B to C is 32 inches. Angle ABC when formed is 90 degrees. A is 20 inches below F. Point A and point F align with the center line of our eye shape. So we have a little bit of information that we have to determine. So we're looking for the area of this green eye shape. So we have to determine the height of the web here, which is in between your flanges. So this elongated rectangle. And we know the thickness, which is 4 inches. So in order to get the height here, we have to get the diameter of our circle. So we're going to have to use our points to get there. Also, as you may notice, our flanges only have a thickness to them of 6 inches each. We do not know the overall width, but we do know it's equal about the center line of this eye shape. So we also know that D and E align along the edge here, and they align vertically right with point C. So we are also going to have to get this distance from the center to C in the horizontal direction, and we are also going to have to get our overall diameter for this circle in order to get the area for these three little rectangles here. All right, so how are we going to start this problem? So let's go ahead and let's work on getting our diameter first. So what I'm going to do is I'm just going to take this portion, and I'm only going to work with this side of the circle that has the points labeled on it, and I'm just going to work with that side. So scrolling on down here, just remove the eye shape because I'm just looking for the diameter here of the circle. So a few points of information that we know that A to F is 20 inches. And let me switch colors here. We know that A to B here, we are told that this is 42 inches. And we know from C to B, we know that this is overall 32 inches. And we're also told that this is a 90-degree angle. All right, so I believe that's all the information that we started with regarding the circle and the points along the circle here. So what are we going to do? Well, F is our center, so we need to get a radius so we can get the diameter. So what I'm going to do here is that I am going to draw a line going from point F and intersecting this member CB, and I'm going to call that G. Now, why did I do this? Well, there is a mix of theorems. If you look at the perpendicular bisector theorem and a chord theorem and you intermix those together, it states that a line that passes through the center of your circle and is perpendicular to the chord also bisects that chord. And you can also theorize this because what happens here if you connect in, oh, that's just ugly, but we'll just draw it on the main picture here. It'd be so much better. We can also theorize here is that when you have connections between FB, FC, and CB forming a triangle here, because this is R and R, the radius of the circle on each side here, you have an isosceles triangle forming. So F is your peak, and then CB is your overall base. So drawing from F to CB with a perpendicular line here will also bisect that member of CB. So what we have here, and let's just stick with black. Oh, come on. So what we have here, since we have a perpendicular bisector, G to B is 16 inches, and now C to G is 16 inches. All righty. So let's draw another line and let's go from F and let's perpendicularly intersect here AB. Well, since AB is not since AB is like this, we are also going to get a 90-degree angle here for our intersection, but we don't know what this distance is, and we don't know what this distance is just yet. We know the total length of AB is 42 inches. But since we have three 90-degree angles here, this would also be a 90-degree angle here. So we have a little rectangle forming within my semicircle. So I'm going to call this point, let's see, H. So since we have a rectangle here, since GB is 16 inches, that means F to H is also 16 inches. So how can I use that? Well, looking from A to H, it's unknown. Well, we know the overall length A to B is 42 inches. So what I can do is I can use this right triangle right here from A or from F, A to H, and I can get this quantity of X here, which I'm just going to label as AH in my equations. So let's go ahead and let's get that length of AH, which just using the Pythagorean theorem will just be the hypotenuse of 20 inches squared, subtracting off the 16 inches squared. And that gives me exactly 12 inches in length here. So this portion from A to H is 12 inches in length. So the overall for AB is 42 inches. So that means that from H to B is going to be 30 inches then. All right, so now I'm starting to get a little bit of distances here. So what was the whole point of doing this 42 with the breaking up into the 30 and breaking up into the 12? Well, what I can do here is that I can draw a line going from H to B. Well, what is HB? Well, since B is along the edge of my circle, that's my radius. Well, I have a right triangle here from the 16 inches from FH and then the 30 inches from H to B. So I can just use the Pythagorean theorem once again with FB being my radius. So FB is equal to my radius, which is equal to the square root of FH squared plus HB squared. So my radius would just be the square root of 16 inches squared plus 30 inches squared. Add those together, square root them, and then we end up with exactly 34 inches as our radius. So that means that my diameter of that circle is just going to be 68 inches. Alrighty, so we just found the diameter of the circle. So if we scroll back up, that means this entire length from here to here is going to be that 68 inches. So I can easily find the area of that vertical rectangle, which is the web of the eye shape. It would be just 68 times the 4 inches. Well, I need to know how wide my flanges are up here at the top. I know that they're equal on each side of the center line of this eye shape. And I do know that D and C and E all align. So I need to know how far off of the center C is. All right, so that's going to be our next portion here, which we're just going to scroll all the way down. And this is a portion of the circle. The red line represents the center line of the eye shape. And of course, here are my points along the edge of the circle. And let's draw in our new points that we just found. This was H down here. And let's draw in this line from, oh, that's terrible. Let's draw in a straight line, or at least attempt a straight line from F to C. And then let's draw in another line from F to B. So we know that this is going to be my radius, which is 34 inches. This one also is the radius of 34 inches. And we know this length over here is 32 inches. And we know this length from H to B is 30 inches. And this one over here from A to H, which is 12 inches. And of course, this was 20 inches here, and that is perpendicular line. So what I'm looking for up here is this dimension X. How far off the center is point C? And there are a couple ways you can go around this, but what we're going to do is that we are going to work to try to find what this angle alpha is. Because this is a right angle forming up here. So once we get this alpha angle, we can go ahead and get x. So how do we get the alpha angle? Well, I'm going to have to determine this angle, which I'm going to call A for this portion of the triangle. I'm going to have to determine this B angle here for this right triangle and this C angle here. So I will add A with B with C and then subtract all that from 180 degrees, and that will give me alpha. So let's go ahead and let's work on getting angle A. Well, we're going to use this triangle from CF to B. We have all the sides known, and we just have one internal side unknown. So whenever you have that situation, we're just going to use the law of cosines in order to solve this. So utilizing the law of cosines, I will have the 32 squared, which is the side that's opposite my angle I'm trying to find. So it'd be 32 squared plus my other two sides squared. So 34 squared plus 34 squared. And then minus off 2 times those sides of 34 and 34. And then finally cosine of my angle that I'm looking for, which is angle A in this case. So rearranging everything, A will just be the cosine inverse of 32 squared, minus off 34 squared, minus off 34 squared, all divided by a negative 2 times 34 times 34. And when you complete this, you're going to get not a nice number, but we're just going to have to round it. And it'll be 56.145 degrees, of course, rounded off. All right, so that's angle A. Angle B and C will be much easier because they're inside right triangles. So for B, we are just going to use the sine inverse of the 30 inches over the 34 inches, opposite over our hypotenuse there. And once again, not a nice number, but it gives us 61.928 degrees once we round it off. Pretty much the same idea for C. We're going to go with sine inverse of our opposite over our hypotenuse, which is 12 over 20. And once again, not a nice number. We have to round it off. So it'd be 36.869 degrees. So alpha will just be 180 degrees because it's a straight line. Oh, not equal to 180 degrees minus off my three angles. So minus off the 56.145, minus off the 61.928, minus off the 36.869 degrees. And we're left with an angle alpha of 25.058 degrees. All right, so now that I have alpha and I have my hypotenuse here, all I have to do is determine that horizontal distance C is off the center line of this member. So that will just be 34 times the sine of my angle, which is 25.058 degrees. And I can do that because this forms a right triangle right here with the sine being the opposite over the adjacent, or the opposite over the hypotenuse, sorry. So X will pop out to be 14.40 inches. So what that means is that if I go back up here to my very beginning here, that means that this dimension is 14.40 inches, and my entire height was the diameter of this circle, which I believe was 68 inches. So now I can get my overall area just by breaking this up into 3 individual rectangles, because this entire distance across here will just be 2 times the 14.14 because it's equal down the center line. So this is 28.8 inches across. And the bottom one is exactly the same because D and E align. So the area of the eye shape, which let's just write it in green just to match the color, is going to be equal to 2 times the area of my flanges, which because I have 2 of them. So it'd be 28.80 inches times 6 inches, plus the area of my vertical web, which will be 4 inches times 68 inches. And this gives me a total area for my eye shape of 617.6 inches squared. Of course, there is some rounding in there. And that's how you would solve that problem. And there are multiple ways that you can work this circle portion. I just showed you one way that you could arrive at the solution. So I hope you enjoyed this video, and I hope you learned a new math skill along the way. And if you want to test your abilities even further, please check out the other videos on our channel, as this is the 20th part in our series for this math skills test. Also, if you haven't done so already, please like this video, leave a positive comment below, and please subscribe to the channel because all of that does help us out. Thank you for watching, and I hope you have a fantastic day.